So this is on finding complete graphs, the second part of 2.2. So remember, when they ask you to find a complete graph, it just means to find a window that you can see everything that's important. So to do that, we're going to do a problem about a company that has two types of costs. They have costs that are fixed and costs that are variable. So a fixed cost might be, for example, if you rent a building, right? You might pay $10,000 a month just to rent that building space. It doesn't matter what you do in the building, whether you use it or you don't use it, you pay $10,000. That's fixed. And then variable, that might be like if you're making a certain product, like I think we're going to do t-shirts in this example, then the more t-shirts you make, the more costs you have. Like you got to buy the blank shirts, you got to buy the ink to print on them, everything you need. So that cost changes depending on if you make 10 shirts a month or you make 10 million shirts. So that cost is variable. Right, so that's what we're going to take a look at. So in this example, this particular company has a fixed cost of $200,000 and a variable cost of $1.50 per shirt. So it's variable because that cost depends on how many shirts they make. If they only make one shirt that month, it's going to cost them $1.50. If they make 1 million, well, it's going to cost them 1 million times $1.50. So it costs them $1.50 to make the shirt, and then they're going to sell the shirt for $4. Bless you. Now there's a few different terms that are going to come up here. Okay, and the terms that we're going to see are cost, revenue, and profit. Okay, so just make sure we understand the difference between them. Okay, cost is basically money that's leaving the company, right? Anything that they have to spend. Sorry. So it's anything they got to spend. So whether it's a fixed cost or a variable cost, that's money they spend. Revenue is money that they take in. Okay? So in this case, it would just be 4 times how many shirts they sell. Revenue isn't necessarily profit. Okay, when you find the difference between the cost and the revenue, that's profit. If you take how much money you took in and you subtract how much you spent, hopefully that's a positive number. If it is, you made money. If it comes out to a negative number, then that means you spent more that month than you made. All right? And that could happen because they have to pay that $200,000 right up front. So they got to sell a certain number of shirts to make that money back. All right? Okay, so what we want to do first is find graphs of two different things, the cost and the revenue. Okay, so remember, revenue isn't necessarily profit, it's just the money that the company takes in. All right, to look at the profit, we got to look at the difference between cost and revenue. Okay, but cost is what they spend, revenue is what they take in. So whether it's cost or revenue, we're going to need a variable that represents something. Okay, what do we need a variable to represent in this case? Yeah.
Shirts sold.
Yeah, whether it's the number of shirts you sell, the number of shirts you produce, we need a variable for the number of shirts sold. So let's pick a letter for that. What would be a good letter?
Let's do X.
Yeah, X. I mean, you could use S for shirts, but sometimes my S looks like a 5.
J. Person.
J?
Yeah. J for
J.
J. You should use J.
We should use J?
J.
Okay, we can use J. So J is the number of shirts. Okay, so we got to first come up with a formula for cost. And when they ask for cost, it's the total cost, the fixed and the variable, all in one formula. Anyone think they could give me a formula that would represent the total cost for this company? Yeah. No. Yeah. Aaron, sorry.
Wouldn't it just be 1.50 or 1.5 times J?
So 1.5J, so that's the variable costs. That covers the shirts they make. But there's still another cost this company has to pay. Yeah, go ahead.
The 200,000 of revenue, so it'd just be plus 200,000.
Right, that's a fixed cost. Okay, so there's a formula that represents the cost. 1.5 times how many shirts you make plus the 200,000.
I've read it. I think the C is making me a little confused because I thought it was a parenthesis.
Oh, you thought there was...
I thought it was just two parentheses.
Oh, two
I was like, why is he
parentheses,
doing
yeah.
that?
Okay, yeah, no, that's a cost.
Okay.
And then revenue. Okay, now what's the revenue going to be? That's just the money that they take in. It would be like the total sales for the month. That's revenue. Yeah?
4J?
Yep, just 4J. Again, revenue doesn't mean profit. It just means how much did they sell. Could be profit if they sell enough. We don't know. That's what we're going to figure out. All right, so we want to graph both of those and then find a window. Okay, so when you're finding a window, what do you have to write down?
That X, X, Y, min, Y, max.
Yeah, just write down all those mins and maxes. Okay, so let's put in, remember you've got to use X as the variable because the calculator, that's what it uses. 1.5X plus 200,000 and then 4X. All right, let's think a little bit about the window. X is the number of shirts that are sold. Could we sell negative 10 shirts? No. What's the smallest number of shirts we could sell? 0. Maybe they just don't sell any. Now, the most number of shirts they sell, we don't know. We could just pick a number. Say they maybe sell up to 25,000. We're going to be looking for something. And if that's not high enough, we might have to go a little higher.
I don't know, maybe we work for Amazon or something.
So what's that?
Maybe we work for Amazon.
Maybe, yeah, they could sell 25 billion shirts. Who knows? So the Y min, that's the money that you either spend or the money you take in. What's the smallest value that could be?
200,000.
In terms of spending, yep, the minimum you spend is 200,000. How about in terms of revenue? What's the minimum you could make?
0.
Zero, right? That's the minimum you could make. If you don't sell any shirts, your revenue is going to be 0. So we do need to go as low as 0, but the minimum cost is 200,000. So we need to go at least to 200,000 on the Y max, and then the slope is positive, so it's only going to go up from there. So we should probably go, maybe we could go like 350,000. And we're going to hit graph, and we're going to see how these look. So let's hit graph. All right, so there's the cost, and there's the revenue. Okay, so that's not a complete graph because I'm looking for something. What do you think I'm looking for? Yeah? I'm looking for where they intersect. So we definitely need to set the X max higher. All right, so instead of 200, what do we have? 25,000. Let's try. We could try 100,000. I think we're gonna have to probably. Well, maybe that's enough. Let's try 100,000. So that's 4 times as much. That might do it. Yeah, we're good. All right, so that's a good window. Not the only window, but that one will work. Okay, so let's just put that down. Okay, X min was 0, even though you can't see it. All right, so X min, X max, Y min, and Y max. Okay, and I can put the graph there too. They didn't ask for the graph specifically, they just asked for the window. But there's the graph. Okay. Any questions on getting that window? Now we're gonna talk about it on the next slide, but this point has a special name. when it has to do with revenue and profit. Yeah. All right, so I think I heard somebody say it. What's this point called where these two things cross? Anybody know?
Break even.
Yeah, it's called the break-even point. Right? Until you get to that point, you're still losing money. Right? When that red line is underneath, you haven't made money yet. And then when you get there, now the money you're making is above what you're spending. So now you're making profit. Okay? So that's called the break-even point. So it's the point at which the cost formula and the revenue formula are equal. Okay? It's when cost equals revenue. So we already answered that question. If you have a graph of cost and revenue, where would it be on the graph?
At the intersection.
Right, it's where they intersect. Hi. You can grab a seat. Yeah, I'll take it. Thank you. All right, so what we want to listen. Okay, what I want to look at now is how many shirts does the company have to sell to break even? All right, so we're going to do it two ways. One way we'll use the calculator to figure it out, and then the second way we'll do it algebraically. It probably would take longer just to use the calculator. I mean, we already did half of it though. We typed in the equations, we set the window, and we hit graph. So I mean that took us maybe about a minute. Now the last thing we have to do is calculate the intersect. Right? So we'll finish that up on the calculator in a second. Okay, so find the number of shirts that the company has to sell to break even. All right. So what did we say in the definition of break even point? It's where what equaled what?
Cost and revenue.
Right. It's where cost equals revenue. So it's pretty much as simple as that. Just take the formula we had on the other page for cost. I think it was 1.5x plus 200,000. That was the cost. Equals 200,000. Oops, sorry. 1.5x plus 200,000. And what was the revenue? What did they sell each shirt for? $4. So the revenue formula was 4. Again, you can use X, you can use J. I'm just using X now because we're graphing it. But again, you can use J if you want. Right. What would be your first step to solve that and get X by itself? Yeah.
Just take subtract 1.5x from each side.
Okay, so subtract the 1.5x from both sides. So that's going to give you 2.5x. And then what would your last step be?
Divide both sides by 2.5.
Yep. Divide both sides by 2.5. And you can check, but I think you get 80,000.
That's what the graph says.
Yeah, and what is that? 80,000 what? Shirts. Yep.
We are working for Amazon.
Yeah, so we got 80,000 shirts. That's what they have to sell to break even. If they sell 80,000, more than 80,000, then they're making money. So algebraically, it's pretty straightforward equation to solve. Okay, let's look at how we do it graphically. Okay, so we've got our graph. I think we've done it before, but under second calc, which option do we want?
5.
Yep, option 5, which is intersect. And remember, you got to hit enter 3 times. Once on the first line you're going to use, so mine's the blue. Once on the second line, that's the red. And the guess here, it doesn't matter because they only cross once. Right? This was like a parabola, and there was a line going through it, and they crossed twice. Well, you got to put the guess closer to the one you want, but the guess doesn't matter. So we hit enter, and that's what we get. So the graph also says that you need to make 80,000 shirts to break even. What's this 320,000? Yep, that's the cost to make 320,000 shirts. And what would the revenue be if they made 80,000 shirts?
0.
Well, the profit would be 0, but the revenue would be...
The revenue would be 120. No.
So if they make 80,000 shirts, it costs $320,000. And then they're also going to take in $320,000. They're going to take in exactly as much money as it costs to make them. That's why it's the break-even point. Okay, so any questions on how we found the break-even point algebraically or graphically? So that was it for section 2.2. So for the rest of today, we're going to focus mostly on 2.3. So some of this definitely going to be a little bit of a review. How to solve linear and quadratic equations. We just solved the linear equation in the last section. The break-even point problem, that was a linear equation. So remember, an equation is any time you have an equal sign, and then you have an expression on the left, and you put an expression on the right. Is that an equation, 2x plus 6? No, that's just an expression. You can't solve that unless you put an equal sign. All right. Now, is that an equation, 2x plus 6 equals? No, it's still not an equation because you got to have something on the left and the right. So there's an expression on the left. There's an expression you could put on the right. Now it's an equation you can solve. Now I used x as the variable. I didn't have to. You can use other letters. X is pretty common. But if you use x, then you can say that this is an equation in x. Saying you have an equation in x just means you have an equation using the letter x as the variable. Sometimes we have equations in y. We use y as the variable. Okay, so solve an equation. What does that mean? Well, it means to find the value or values, it could be more than one, that make the equation true. Generally, when you're solving a linear equation, you can have, the normal case would be you get one solution. You can get no solution or infinitely many. Now, those are special cases. But the standard case is you get one solution. And how about for a quadratic? What's the most number of solutions you could get for a quadratic? Yeah? 2. Yeah, you can get up to 2. You can get 1, or you could get none. The way you could visualize it is think of a parabola and imagine drawing it. How many times could it cross the x-axis? Could be twice. Could be none if you shift it up and you draw it like this. Never crosses the x-axis. Or if you do it just right, could come down, touch the axis, and go back up, and it just touches once. Right, so we'll talk about those cases when we get to quadratics. So one type of equation, this would be more of a special case, is called an identity. Okay, an identity is an equation that is always true. Okay, it's always true. means you can plug in any number you want and it'll work. Now, when I say you can plug in any number, you can't plug in a number that would cause you to divide by 0. That's not in the domain. You can't plug in a number that would cause you to take the square root of what kind of number? A negative. That's not in the domain. Okay, but I mean, all numbers that are in the domain would work. So let's look at that one. We'll write out the first 2 steps. And we're going to see very quickly that that's an identity. What would be the first thing you do on the right side there?
Distribute.
Yeah, distribute what?
The 3.
Distribute the 3. So when you distribute the 3, you don't do anything with the -1. That stays the same. You're just distributing the 3 to what's in parentheses. Corbin, what could I do now on the right-hand side?
Do 3 minus 1.
Right, you combine like terms. And what do you get when you do 3 minus 1? 2. So you get 3x plus 2 on the left. You get 3x plus 2 on the right. So the next step, you might think, all right, I'm supposed to get all the x's on the same side. Well, you can. But if you subtract 3x and move it to the other side, it's going to cancel on both sides. And you're basically left with this. 2 equals 2. Whenever you get an equation and all the variables disappear, you're done. At this point, when you get a number on the left and right that are the same, that means it's an identity. 2 equals 2. Okay, so no matter what you fill in for x, you're going to get exactly the same thing on the left and on the right. And is there a fraction in this problem? Any fractions? No. How about any square roots? No. So that means there's no problem with any number you want to fill in for x. Positive, negative, fraction, decimal, or 0. Any number you can think of that's a real number will work. Now, compare that to this kind of equation. This is not an identity, 2x equals 10. Because you can't pick any number you want and plug it in for x. There is, in this case, one number you can pick. So there's a condition that makes that equation true. What would be the number you could pick for x here? Yeah, you could pick 5, and that's the value that makes it true. Any question on the difference between an identity or a conditional equation? So how do you check, once you get an answer, how do we check and see if it works? Well, we can take that answer, plug it back in, and see if we get a true statement. So on this last one, I didn't solve it, but I asked somebody what the answer was. They said 5. Okay, the way I could check that 5 works is take 5, plug it in for x, and I put a question mark there because I wanted to see if that's true. And if I fill 5 in, I get 2 times 5 on the left. 2 times 5 is 10. Equals 10. That's how you know you've checked an equation and the answer works. You get a true statement. 10 equals 10. Now, if you got something like 8 equals 10, well, either you plug the wrong number back in, or maybe you plugged in 4. 2 times 4, that's how you could get 8. Or maybe you plugged the right number in, but you made a mistake when you checked it. Any questions on what it means to check your answer? Okay, so again, a lot of review, I think, on this so far. All right, so here's an equation, and I'm going to have you not solve it, because that could be a little tricky to solve. Why could that one be tricky to solve?
Because there's an exponent.
And what is the exponent?
Q.
It's a 3, right? We've got a formula for handling this. If the exponent was a 2, right? We could use quadratic formula, or we could try to factor it. But that's a 3.
That's true.
We can't use quadratic formula.
What do we do?
So we're just going to check that -2 is a solution. At this point, you don't have to know how to find the -2 in this problem. I would give it to you. You're just going to check it. Maybe I'll give you a number that works. Maybe it doesn't.
Why -2?
Because it works.
So.
So let's check. So it says verify -2 is a solution.
Thank you.
Usually if the question is worded that way, to me, it's kind of telling you -2 is the answer. They just want you to check it. Okay. Now, if I wrote the question, check if -2 is a solution to the equation. Now I'm not really telling you whether it is or whether it isn't. You have to check it and see if it works. Okay, so how are we going to check if -2 is a solution there? Corbin?
You can start by plugging 2 into where the x's are, -2.
Yep, so we're going to plug -2 in everywhere we have an x. And again, I'll just put a question mark there because this is a check. We don't know if it works yet. We're going to see. And Brady, when I do this out, what's -2 cubed?
Negative.
It's going to be -8. And we can do this at the same time. -2. That's going to become +2. Again, that's what we're still checking to see if it works. Add up -8 plus 2. That's going to give me -6. And then -6 plus 6? 0. So we get 0 equals 0. Is -2 a solution?
Yes.
Yes, it is. Okay, when we get to chapter 3, actually it might be chapter 3 or 4, I can't remember which one, we are going to learn how to figure that number out. Like how can you get -2 as an answer to that? And because it's a nice number, we can do it. Okay, if the answer comes out to like a decimal that's really difficult, we still wouldn't be able to do it. But this one we could do, because the answer is a nice number. But that's later on. Okay, any question on that? Okay. So what is a linear equation? Well, what's one format that you often use to write a linear equation? Yeah?
Y equals mx plus b.
Yeah, you can write y equals mx plus b. So an example might be like y equals 3x plus 6, something like that. That's a linear equation. The point is you have a number with x and then a number at the end. And that's exactly what I'm putting right here. You have a number with x, and then you have a number at the end. And it could be equal to 0, it could be equal to y. A lot of times we want to get it equal to y. Now, anyone remember what that symbol means?
All real numbers.
All real numbers. So what this is saying is a and b are real numbers. That's what that says. A and b, if you want to be like specific on how it translates, a and b are elements of the real number system. So a and b can be anything you want. Positive, negative, fractions, decimals. But there's only one thing a can't be. And it tells you that right at the end. A can't be 0.
So.
A can't be 0. Because if a was 0, and you filled in a 0 for a, you'd have something like 0x plus 3. I'm just making up a number for b. What's 0 times anything? 0. So if you do that, this cancels out. And now you just have b equals 0. Okay, that's not a linear equation. Right? To have a linear equation, it has to have a slope that's not 0. If the slope is 0, we call that a constant equation. That's like a horizontal line. Okay, that's a constant. Linear equation is usually on it's on a slant. Okay, positive or negative. But it's on a slant. All right, let's try solving a linear equation. Okay, this would be a first equation I would jump into solving linearly, but hopefully by this point you're pretty comfortable solving that. So if you forget how to solve it, the way I explain it when I teach it in like Algebra 1, is I tell them to remember SAM. So the first thing we do is simplify. And simplify means we could have distributive property or combining like terms. And we do them in that order. Distributive property, then combining like terms. After we do the simplify, we check if there's any adding or subtracting we need to do. That would be the next steps. And the last thing is any multiplying or dividing. So SAM is how I explain to remember when you're solving equations. Some people mix that up with PEMDAS. PEMDAS is not for solving equations. PEMDAS is for doing arithmetic. This is not arithmetic. This is algebra. All right. So let's look at this and see what we do first. Is there any simplifying because we have distributive property or like terms? Yeah.
Yes.
Yeah. What do we have to do for the distributive property?
You have to take 2 into 2x minus 3 and 3 into 3x plus 1.
Yep. So we got to do both of those. Ethan, if I do that, what's 2 times 2x minus 3?
Okay, so 2 times. It's like going to be 4x.
Mm-hmm.
Yeah, and then negative 6.
And then negative 6. Okay, so there's the first part. Now remember the second part, this is what can trip people up sometimes, especially if that's a negative symbol. That is what you're distributing. The sign with the number. So if it was a negative 3, the negative gets distributed. In this case, it's a positive. So you're just distributing positive 3. Ella, what do we get if I distribute the 3 to the x plus 1?
3x plus 3.
So we get 3x plus 3. And then did anything change on the right? No, not yet. So the next step under simplifying is to combine like terms. Combine like terms is on the same side. So we're not moving stuff from side to side yet. We're just combining anything we can on the same side. Well, on the right, we only have 2 terms. One has an x and one doesn't. So there's no like terms on the right. How about the left? Any like terms there, right?
4x goes with 3x and negative 6 goes with 3.
So we can combine the 4x and the positive 3x. And then what else did you say?
Negative 6 and 3.
Negative 6 and positive 3. Okay, so let's combine those, and then we're going to be done with the simplify step. What do I get on the left-hand side for my x's? 7x. And my constant?
Negative 3.
Negative 6 plus 3 is negative 3. Okay, now we're into the adding and subtracting. So anything we can add and subtract from side to side to start to get x by itself. Anyone see something we can add or subtract?
You can add
Minus 3?
Okay.
Oh, add 3. Okay. So we can add 3. That's going to cancel those.
And subtract the 5.
We could subtract the 5x at the same time. That's going to cancel those. Okay. What's on the left side now? 2x. And the right side is 5. Okay. So we've done all the adding and subtracting we can do. Last step. Is there any multiplying or dividing? Yep.
Divide 2 by 5.
Yep. Divide 5 by 2.
Or 5 by 2, yeah.
So you can leave your answer as 5 halves. If they asked for a decimal, you could put 2.5. I would say generally we don't use a mixed number. Okay. So improper fraction or decimal. Okay. Any questions on that one? So that's solving a linear equation. An application of solving linear equations is solving absolute value equations. What we're going to end up doing here is solving two linear equations. So let me just show you something first, and then I'll come back to the steps. Now, if I set this up, okay, just like that, and don't even look at what's inside here. This doesn't even matter. Now, there's two numbers that what's between these bars can come out to, and we would get an answer that's correct. What's one thing that the answer could come out to between these bars, and when you take the absolute value, you'd get 4? Yeah?
-4.
You could have this come out to either a -4, and then when you take the absolute value, you get 4. Or what's inside these bars would have to equal +4. Right? So when we solve it, we end up setting up two equations. Either what's inside there equals 4, or what's inside there equals -4. And that's how you solve absolute value equations. Now, this one was good because the absolute value bars was by itself. But if you had this, let's say -6 plus, now you have that absolute value. That's not ready to solve. When you want to solve an absolute value problem, this has to be alone on one side. You can't have anything else outside the bars. So this -6 would have to move to the other side. How would you get rid of this -6?
Add it.
You would add it, and then you'd have absolute value of 3x plus 12 equals 10. Okay. I'm not going to go through and solve that one. We're going to do one simple. Okay. But that first step, okay, I refer to that as isolating the absolute value. Okay, so that's your very first thing you have to do. Isolate the absolute value so it's by itself. And then we're going to split it into two problems. So the first equation that you split the problem into, you just take the problem they give you and you erase the bars.
Yes.
Okay. Take the problem that they have and just wipe the bars out. So like if I was doing this one, where was it? Just put it back the way it was. I would do 3x plus 12 equals 4. And the second equation is going to be taking the number on the other side and negating it, okay, making it the opposite. 3x plus 12 equals -4. So in both of them, it's without the bars. That's why you split it, okay, to get rid of the bars. But the second one has that extra step of making the number on the other side a negative. Later on, either tomorrow or Wednesday, we're going to talk about solving absolute value inequalities. Right? So instead of an equal sign, we're going to have like a less than or a greater than. And the steps to solve those are going to be exactly the same as these two steps. So these two steps will be used a couple times this week. All right, so let's look at this one. Absolute value of 2x plus 3 equals 5. So first question to ask yourself is, look at the absolute value. Is it by itself on one side?
Yes.
Yes, it is. Okay. All the stuff is inside the bars. There's nothing outside the bars. So After isolating the absolute value, we can split it into two equations. Anyone think they could give me my first equation that would split into? Yep.
2x plus 3 equals 5.
Right.
The original.
Either what's inside the bars comes out to 5, or what's inside the bars comes out to negative 5. And now this is where solving a linear equation comes in. We have to solve two of them. Even though you have to solve two, it's usually not as complicated as a problem like that. There's usually no distributive property. I would say that's usually as complicated as the equations get. All right, let's start with the one on the left. Landon, what would be my first step to solve the equation on the left?
Subtract by 3.
Yep. So we're going to subtract 3 from both sides. And what does that give me for a new equation?
X equals 1.
Sorry.
Yes, eventually we'll get there.
Yeah.
2x equals 2.
So 2x equals 2. And then when you divide each side by 2, you get
X equals 1.
x equals 1. So what I would probably do on Edge Elastic is I'd have 2 boxes. And then if you get one right, you get half credit, things like that. But that would be your first answer. X equals 1. Now, the steps that you use to solve this one are exactly the same steps on this one. So what's our first step on the one on the right? Subtract the 3. So that's gone.
2x equals negative 8.
So it gives me 2x equals negative 8. And then my last step.
X equals negative 4.
Divide by 2. And that gives you what?
X equals negative 4.
X equals negative 4. Okay, so that's an absolute value equation. Again, something you did in Algebra 1 probably a while ago, but just kind of reviewing it here quick. But any questions on that? Okay. All right, so last application of a linear equation is solving, we're going to do solve a mixture problem. There's different ways to set these up. I'm going to give you one way that I do it. In another class, they mentioned they had like this table thing they learned how to do. If you've got a different way, that's fine. So when we're solving a mixture problem, what we're going to have to do is set up 2 equations. Okay, this kind of problem, they're generally going to say something like, you've got 2 different solutions. Maybe one solution is like a 10% strength and the other one's 20%. And I want to mix the 2 together to get 13%. And I want to end up with 50 gallons. So I have a certain amount that I want to end up with, and I have a certain strength that I want the mixture to be by mixing the 2. Right. That's kind of what these problems are. So the first equation you set up has to do with the amounts. I usually just call them A and B. Like A is the amount of liquid I use from solution number 1, and B is the amount of liquid I use from solution number 2. And if they told me in the problem they want 50 gallons, I would write A plus B equals 50. Now, if that's all I knew, there'd be a lot of answers. I could do 49 gallons of one and 1 of the other, that's 50. Or I could split it, 25 and 25. But what's going to narrow down the answer is they're going to tell you the concentration they want. That's like the strength of the solution. In that equation, it's really the same thing repeated 3 times. The concentration of the first solution times how much you use of that solution, plus the concentration of the second solution times how much you use of that solution. Concentration will usually be given to you as a percent, like 10% strength, 12%. We just have to make sure we always put the concentration as a decimal. in all of them. So you have a concentration times an amount, plus a concentration times an amount, and then you're going to have the final concentration, which is given to you in the problem, times the final amount of liquid they want you to make. So in terms of what you're going to have to fill in, or actually, I'll highlight what's going to be given to you. That'll be given. That's given. That's given. That's given. And that's given. The only thing that's not given is amount 1 and amount 2, which I just usually use the letters A and B. Amount 1 and amount 2. But everything that's in green, you'll be given. Any question on those two formulas before we try? Yeah.
Is the concentration equation that equals his concentration times total amount? Or?
That's the final concentration times the total. I guess I could put final total there.
The amount of liquid?
Right, and they'll give you that in the problem. Yeah, they're going to give you that part in the problem. Okay, so I can scroll back up so we can see those as we're trying to do them. And here's our problem. So we have two solutions, A and B. A is a 10% solution, B is a 25% solution. Now we're going to mix A and B together, and we can create any strength in between 10 and 25. Okay, it just depends on how much we mix of one and how much of the other. They want us to mix these together so that when we're done, we end up with exactly 15 liters, and they want the strength of the solution to be 12%. Now, since the strength is going to be 12%, we're probably going to use more of solution A than solution B. Because we're not bringing the concentration that much up. We just have to pour a little bit of B into A to make A a little bit stronger, so it's 12%. But we got to figure out how much. So what I'll do here, just to make it clear, since they've already named the solutions A and B, I'm going to let A be the amount I use for the 10% solution, and B is how many liters I use of the 25% solution. Just makes sense to use those two letters because that's what they called the two solutions. Okay, so how much of each solution do we need? All right, so when you're setting up a mixture problem, how many equations did I say you need?
Two.
You need two. Okay, the first one is just the amount of this first solution plus the amount of the second equals the total. How much are we using of the 10% solution? How many liters? Well, we don't have a number for it yet. How are we representing how much we're going to use? Yep. A. How are we representing how much we're going to use of the 25% solution? B. So how would you fill in this first equation? Amount 1 plus amount 2 equals the total.
A plus B
Equals what?
A plus B equals 15.
A plus B equals 15. Yeah. The amount from the first solution plus the second solution has to equal 15. So there's your first equation. Now the second one is going to be concentration times amount. Concentration times amount. Final concentration times final amount. That's this one right here. So let's go through and fill in. Everything in green is going to be a number. Anything not in green will be a letter, either A or B. Okay, so what's the concentration of my first solution? 10%. And how would you write that as a decimal? 0.1. So 0.1. And how much of the 10% solution do we need?
A.
We need A. Okay. Concentration of my second solution. 0.25. And how much of the 0.25 solution do we need?
B.
We need B liters. And then what's the final concentration?
12.
So 0.12. And what's the final amount? 15. Now, because the right-hand side is all numbers, we can multiply 0.12 times 15. Okay, I'm not going to rewrite the whole problem just for that, but in the next step, I'll put down what that comes out to. Anyone have a calculator? Tell me what 0.12 times 15 is?
1.8.
1.8? All right, so next time, I'll write that down. Okay, so I'm going to get rid of all my parentheses here. So I'm just going to have 0.1a plus 0.25b equals 1.8. Okay, so there's your second equation. There's your first equation. So the way we're going to have to solve that is we have to do something with this first equation and then fill it into the second one. Does anybody know what we've got to do with that top equation? Yeah?
Isolate a variable.
Right. We've got to get either the A or the B alone in this top equation and then fill it into the bottom. It doesn't really make a difference which variable you get by yourself. Which one do you want to get alone?
A.
A? Okay, so if we get A alone, what would A equal in that top equation?
15 minus B.
15 minus B. Okay, now you've got a formula for A. You've got 15 minus B. What am I going to do with that 15 minus B? Right, you're going to plug it in everywhere you have an A. So take 15 minus B and fill it in for A. Okay, anybody remember what that's called?
Substitution.
Yeah, substitution. Yeah, we're just substituting the A for a formula. So you're going to have 0.1. And anytime you do substitution, you always want to keep your parentheses because distributive property usually comes up. Now this time, don't write A. Put what A is from the first one, 15 minus B. Nothing else is going to change. Now, if you do the substitution correctly, you should have an equation now that just has one letter. Right? And we do. Just one. It may have the letter more than once, but it's just one letter. It's just B. All right. What do we do with the 0.1? Distribute. All right, we'll see how much we can do, and then if we need a calculator, we'll bring that up. What's 0.1 times 15?
1.5.
1.5 minus 0.1b plus 0.25b. Okay, any like terms I can combine on the left? Yeah.
0.35b.
So what are you combining the 0.25 with?
The 0.25b plus the whole point b, 0.1b.
Careful, it's not a 0.1b.
Negative 0.1b.
It's
sorry.
a negative 0.1b. So you can combine that with that. And what does that give me?
0.15.
0.15, yeah, 0.15b. All right, so I think we've got all the b's on the same side together. What could I do next?
Subtract 1.5.
So we subtract the 1.5, yep. That's gone. And I think we're still okay. We can probably do this so far without a calculator. What's 1.8 minus 1.5? 0.3. 0.3. And last step to get b by itself. By 0.15. And we are going to get a nice answer there. How many times does 0.15 go into 0.3? 2. Yeah. So solution B, we need to put 2 liters. And we know we had a total of 15. So how many liters of solution A? 13. And that's a mixture problem. Pretty much every mixture problem is just like that. The only thing that's different is the concentrations you're given and the total amount of liquid that they want you to get. But you solve it the same way. Yeah. Question on that? The last thing we're going to look at, quadratics. So linear equations basically have a number with x plus a number. Quadratic equations have a number with x squared, then a number with x, then a number. And the a, the b, and the c can be any real number that you want, except a can't be what number? 0. Because if you put in a 0 right here, and you multiply 0 times x squared, what would you get? You'd get 0. Now you'd have this. That's not quadratic anymore. That's just bx plus c. What would that be? That would be linear. So if you make a 0, you wipe out your quadratic. Okay, a few different ways we can solve quadratics. Does anybody remember one way that you learned before you learned quadratic formula? And this way works as long as the numbers are nice. Yeah?
Factor?
Yeah, you can factor. Again, factoring is good. It's quick if you know how to factor. And the numbers work out nice. All right, let's try a factoring one. Now, regardless of what the numbers are, what's the first thing you always write down if you're going to factor something? This doesn't have anything to do with numbers. Even before signs. Before even that. We are going to write down letters, we're going to write down signs, but we need to write down, when you're going to factor, you need to put numbers. You're going to have numbers in there too, but we got to put these in a certain thing. We need some symbols. We need parentheses. So anytime you're going to factor, first thing you want to do is that. And we always want to make sure that it's equal to 0. In this problem, it already is. But if there was a number over there, it needs to be on the other side. All right. Now factor. So the first thing we got to figure out is something times something. That gives me 2x squared. Yeah?
1x and 2x.
Yeah, we're going to need like a 1x. 1x and a 2x. That's good. Now, up top, your middle was positive and your constant was negative. Does anybody remember what kind of symbols we need down below?
Positive and negative.
Right. And this part's not a guess. You can't, there's no guess. It's got to be a positive and a negative. It does matter which one you put where. It could be a positive and a negative. I would probably do a negative and a positive. If you did it wrong, you could you'll see it's wrong. You can switch them. And now we need two numbers that multiply to give us 3. 1 and 3, and I would do them exactly in that order. Okay, so when we check it, you FOIL it or you distribute it out. And the only thing we have to make sure we get is the 5. We picked the 2x and x to give us 2x squared. We picked the -1 times 3 to give us -3. The only thing we didn't pick was the middle, but that has to happen. Okay? So 2x times 3 is how much? 6x. And what's -1 times x? -1x. 6x
Oh my god,
is 1x. Isn't that perfect? Look at that. Beautiful.
So beautiful.
All right. Now we've got something times something gives us 0. What's the only way you can multiply two things together and get 0? Only one way that could happen. Yeah?
One of them equals 0.
One of them or both of them would have to be 0. Either the first one is 0 or the second one is 0. To solve the one on the left, we add 1 on both sides. And here we would get x equals a half. Yep, good. Half. And now solve the one on the right. Well, there's only going to be one step there. What did you get for x on that one? -3. And that's how you solve a quadratic if it's factorable. Now, if it's not, there's something else we could use. Quadratic formula. You can use quadratic formula all the time. It's just on a problem like this, I could factor it faster than quadratic formula. Quadratic formula is a bigger formula. I got to do a lot more stuff.
And I just always use quadratic.
You can always use quadratic. Yeah, you can always use it. So if factoring doesn't work, or you're not a big fan of factoring, you could use quadratic formula. Okay, you do have to make sure you remember all that. Okay, so it's a little bit more to remember than when you have to factor. But it's -b plus or minus the square root of b squared minus 4ac all over 2a. Now you also have to remember where the a, the b, and the c come from. The a has to be the number in front of x squared. The b is the number in front of x. And the c is the number that's at the end. And you have to make sure it's equal to 0. But that's the same as factor. Okay, it has to be equal to 0. So that's what I just told you. So to use quadratic formula, you've got to make sure your equation is in standard form. So when you do quadratic formula, usually you end up with an answer like 3 plus or minus square root 5 over 2. Plus or minus. That's how you get the two answers. Plus or minus. All right, let's try this one. So maybe this one would factor, but I don't think it does. Whether you were going to try to factor or to use quadratic formula, what do we always have to make sure that it equals before we start?
0.
It's got to be equal to 0. So, what would we do on both sides to get that equal to 0?
Subtract by 1.
Yep, subtract your 1. Perfect. Now, what I like to do is just identify maybe on the side what A, B, and C are, so we don't make a mistake. What's A in this case? 2. B, also 2, just a coincidence. And then C, -1. Now, we are dealing with real numbers in this chapter. So if you get an imaginary, if you get a negative under the square root, you probably did something wrong. Okay, so quadratic formula, what's the first thing I write down? Negative b, all right.
Plus or minus square root of 4.
Yep, I usually do this part out. B squared is 4.
Minus 4. Parentheses 2. And then 2 and then negative 1.
2 and then a negative 1.
All divided by 4.
And that's all divided by 4.
2.
Yep. And now we're going to simplify that as much as we can. Now look at this part. I don't know if I said it, but I wrote it. The part under the square root is called the discriminant. In our discriminant, we're subtracting a negative number. So what happens when you subtract a negative? It's going to become a positive, so I might as well just make that a positive. And now I'm going to get square root of 4 times 2 gives me 8 times 1, 8 plus 4, 12. So square root of 12 over 4. And the square root of 12 is a square root that simplifies. Can anyone think 2 numbers that multiply to give me 12, and one of them you can take the square root of in your head? 3 and 4. So think of the square root of 12 as 2 square roots separated into 4 times 3. Now what, you should have a square root there that simplifies. What root is going to simplify? Square root of 4, which is how much? 2. So now we have negative 2 plus or minus 2 root 3 over 4. And now, since we simplified that, what number is everything divisible by that's outside of a root? 2. 2 goes into itself how many times? And then 2 goes into 2 and into 4?
2.
Twice. So the final answer you get is negative 1 plus or minus. You don't have to write 1 square root of 3. You can just write square root of 3. And that's divided by 2. Okay, so that's the final answer, as simplified as you can make it. And you do have to reduce those square roots, so if you get something like square root of 12, square root of 20, things like that, you got to reduce it. Any question on that? Okay. Yeah, that, and then. All right. So I know there's a lot of different things in that section. Hopefully, most of it was review. So page 89, that's a break-even point problem, 35 to 39. They're all questions that are connected. And then page 96, that's what we spend all the time with solving linear and quadratic equations. Okay, reminder, I will be after school Thursday. So if there's anything you need to get taken care of before progress reports, Thursday would be the day to get that done.